So let's take a look at another problem involving the law of cosines. So in this case, we want to solve triangle ABC with A equal to 8, B equal to 18, and C equal to 13. What this tells us is we have a situation where we know all three sides. So A is 8, B is 18, and C is 13. All lowercase letters indicating all sides, and so this is a side, side, side triangle. So when we set up our table to solve the triangle, we'll be filling in all of our values on the right side. Now, it may seem like we can start wherever we want to for figuring out an angle. We're going to have to figure out all three eventually anyway, so it may not seem like it makes a difference where we start. But it actually does make a difference. We always want to start with the angle excuse me, that is across from the biggest side. So if 18 is the largest of the three sides, that means that angle B is going to be the largest of the three angles. And so that's where we want to start. Because if there's going to be an obtuse angle in our triangle, it would have to happen here. And that's going to affect what answers for A and C are going to be as acute angles if this angle ends up obtuse. So it's always best practice to start with the angle that is across from the largest side. So now when we set up our law of cosines, we're actually going to start with the 18 squared, that's across from the angle that we're interested in, and make that equal to the 8 squared plus the 13 squared minus 2 times 8 times 13, and then the cosine of B. So the trick to this problem is making sure that we follow proper order of operations when we're solving for B, because this is where our variable is. This is what we have to get down to. Alright, so let's just start doing some evaluating here. 18 squared is 324. 8 squared is 64. 13 squared is 169. 2 times 8 times 13 gives us a 208. So we're subtracting 208 times the cosine of B. Now we could go ahead and add the 64 with the 169, which would give us 233. We cannot, however, subtract the 208 from that, because the 208 is being multiplied to the cosine of B. So that has to stay a coefficient on my cosine B term. So that means I can subtract the 233 from both sides to get 91 equal to negative 208 cosine B. Okay, and then I would need to divide both sides by the negative 208. And then to get B, I need to take the inverse cosine of this. That's going to get me my B angle. Okay, so again, let's go to our calculator. I need to take the inverse cosine, so go to my trig and go to inverse cosine. And I can just go ahead and type in 91 divided by negative 208. Hit Control Enter to get a decimal, and we get about 115.9 rounded to the nearest tenth. So 115.9 is our B value, and that's what's going to go in right here. Okay? Now that I have an angle, now I can find another angle by using law of sines. Oops. So we can go back to using the law of sines now. It's not an either or thing. We use whatever formula, whatever law fits the information we have. So I can now take these two as being corresponding. So the sine of 115.9 over 18 will have to equal whichever other one I want to do. So let's go ahead and do the C first. And that's going to be the sine of C over 13. Now again, notice our variable is the C that's inside of sine. So when we take our 13 times the sine of 115.9, all divided by 18, that's what the sine of C will equal. We'll have to do an inverse sine to actually get C itself. So back to our calculator. 13 times the sine of 115.9 divided by 18, Control Enter, gives us 0.649681. That's what the sine of C will equal. So now when I do inverse sine of my previous answer, I get about a 40.5. So back over here for angle C, we're getting 40.5 to the nearest tenth. Okay, and then finally, in order to find angle A, we do that one third. Since we have the other two angles, angle A is simply a matter of taking 180 minus the 115.9 minus the 40.5, and we end up with an answer of 23.6. So 23.6 degrees. Okay? Now again, law of cosines, just like law of sines, can be used in application situations. You see there's one there in your notes page on your book. And the application says this. It says the pitcher's mound on a women's softball field is 43 feet from home plate, and the distance between the bases is 60 feet, as shown in the figure. So you can see here we've got 60 feet from home plate to first base. We've got 43 feet here from home plate to the pitcher's mound. We've got H labeled here because that's what we're being asked to find. How far is the pitcher's mound from first base? So that's our H labeled right there to help us find that. And then they've labeled 45 degrees here because the softball diamond is a square oriented as a diamond, so this is a right angle just like all of these are, and half of that is going to be that 45 degrees. Now we cannot just set this up like a right triangle because of this piece of information right here. The pitcher's mound is not halfway between home plate and second base. If it was, then we could assume that this is going to make a right triangle and we could work it as a right triangle. But it is not. So we're going to have to work this as a regular triangle and then decide how to set things up. Okay, so again, it is not necessary to go through all of the steps to solve the entire triangle. All we need to solve for is that h right there. Okay, and when we look at what we have, what we have is two sides with an included angle. So that seems like the perfect situation for law of cosines. So the h is what we're trying to find. It's across from the angle that we know. We're going to set that up by taking 43 squared plus 60 squared, those are the two sides that we know, minus 2 times 43 times 60 times the cosine of our 45 degrees. Okay? And because h is our variable over here already isolated somewhat, it's being squared, but it's already over here on the left side by itself, we can simply go to our calculator and type all of this in. So let's do that. 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. Hit Control, Enter, and we end up with 1,800.33. Now remember, that is what h squared is equal to. So now in order to get the actual h value, we need to go back. We need to take the square root of our previous answer, and that gives us an answer of about 42.43. And everything was measured in feet, so that would be 42.43 feet. So this distance right here between the pitcher's mound and first base should be about 42.43 feet. And again, we're just using the law of cosines to find the missing piece. We do not have to solve the entire triangle in an application problem like this. All right, so that should be the information you need in order to do the 3.2 practice. Keep in mind that even though you may need to use the law of cosines as a first step, once you have used the law of cosines to find a missing piece, you may be able to use law of sines to continue. So you might find that you're doing a mix of law of cosines and law of sines in this lesson, and that's fine. That's totally how you should be doing things. If you have any questions, make sure you seek out help, either from me or from someone else who can answer your questions for you, and we will see you next lesson.